Welcome to our communication. Today we will start with multi-tone AM modulation system. Multi-tone AM modulation system. Multi-tone AM modulation system. Okay, amplitude modulation. That is AM modulation. AM system. We can say AM system. Okay. In AM, the multi-tone means we have more frequency. We can say more than one frequencies in our message signal. Okay, more number of frequencies in our message signal. It means that if here we can write it SMT is equal to AC, we know the expression where 1 plus KAMT cos 2 pi FCT. That is the expression. No? Okay. Now here in place of MT we are writing not only one frequency, but we will write more than one frequency. That is, now for multi-tone AM system the expression will be the AC into 1 plus KAM AM 1. I am writing here AM 1, okay, cos 2 pi FMT FM 1T, okay, plus KA AM 2 cos 2 pi FM2 T, so on. But I am writing here for only two frequencies, that first one is FM1 and second one is FM2, okay, into cos 2 pi FCT. Then KM1, that is KAM1 AM1 is our first modulation index, and KMAM2 is our second modulation index. Okay, that is first modulation index and second modulation index, mu1 and mu2. Okay, now we can write in terms of SMT is equal to AC into 1 plus mu1 cos 2 pi FMT FM1T plus mu2 cos 2 pi FMT FM2T into cos 2 pi FCT. I hope it is clear, na? I am not I am just writing in terms of now multiplying cos 2 pi FCT, and we want to draw the spectrum. Then in the spectrum we can see that what we have, the what we can see that this is basically our frequency F, and this is the SMAMF. Then is at the time of FC, this is FC, this is minus FC. Okay, what will happen? First one is cos 2 pi FCT, second one is cos 2 pi F1T into cos 2 pi FCT, with what that will give us FC plus F1 and F1M, that is FC plus F1M and FC minus F1M, and there is a image in left hand side, that is minus FC minus F11 and minus FC plus F11, okay, and also cos 2 pi FM2 T into cos 2 pi FCT, that will give us FC minus FM2, that FC plus FM2 and FC minus FM2. This will at FC plus FM2 T, this is at FC minus FM2 T, and there is a mirror image of these two here. I hope it is clear, na? Okay. And what will be the maximum frequency? Maximum frequency of the highest frequency. If F1 is highest or F2, FM2 is highest, then the highest frequency we can see that highest frequency will be the bandwidth, total bandwidth. Okay. Now we want to calculate power of this multitone AM signal, multitone AM signal. Okay, what will be the power? Power is basically PT into PT plus PSB. PT is clear, our sorry, PC plus PSB, and PC is already clear. Our we have more than one sideband. Here we can see more than one sideband. This is sideband. Okay, then we can write it as PC plus P USB 1 plus P USB 2 plus upper sideband, and P LSB 1 plus P LSB 2. I hope it is clear. Now PT will be what? PC plus P USB 1, that is the power is same na in both. We can write it, and in this also power will be same, so we can write 2 into AC square mu 1 square divided by 8R plus AC square plus mu 2 square by 8R. I hope it is clear. In previous class we have already derived all the expressions, so that we need not to write, need not to derive once more time. Okay, then what will be the PT? PT will be PC in plus AC square mu 1 square divided by 4R plus AC square mu 2 square by 4R. And what will be the PC? PC is AC square by 2R. In when we take a common AC square by 2R, that is PC, we are what we are taking, PC is we are taking common, then 1 plus 1 plus what will be the 2R will be common, then mu 1 square plus mu 2 square divided by 2R 2. Okay, then we can write that mu mu as a equivalent. Mu equivalent will be, we can write mu 1 square plus mu 2 square. Then we can write it as PT is equal to PC into 1 plus mu equivalent square divided by 2. I hope it is clear, na? And similarly for modulation, IT is equal to the expression we have already derived, IT equal to IC into 1 plus, here we can write it mu in term, for mu, here we are writing mu equivalent square divided by 2, and VT is what? VC into 1 plus mu equivalent square divided by 2, and for modulation efficiency, that is eta is equal to mu equivalent square divided by 2 plus mu equivalent square. I hope it is clear, there is no doubt. Okay, we want to just solve one numerical. Solving one numerical question is what is the question? Question is given as, suppose an unmodulated transmitted power is given by transmitted power is given by 10 kilowatt. Okay, here 10 kilowatt transmitted power is given. Here unmodulated means mu is equal to 0. For that our PT is equal to given as 10 kilowatt. That means it is given, what is it is giving? It is giving PC, the power of carrier. Okay, then when the carrier is modulated by a single sinusoidal message signal, when this when its carrier is modulated by when its carrier is modulated by a single sinusoidal signal. Single sinusoidal signal. Okay. Then power is increased by 13.5 kilowatt. Increased to. It means 3.5 kilowatt power is increased when we modulated with a single sinusoidal signal. Okay. Then question is find the AM transmitted power if the carrier is a second sinusoidal signal with 60% of modulation. 60% of modulation. I hope question is clear, na? Here PC is given as 10 kilowatt. Okay. PC is given as 10 kilowatt because PT is 10 kilowatt when mu equal to 0. It means that at that time PT equal to PC, na? It means it is given as 10 kilowatt. I hope it is clear. We have already solved some numericals on this type of problems. Okay. And PT is equal to 13.5 kilowatt when we are modulating with a single sinusoidal signal. Okay. PT is what? PT is equal to PC into 1 plus mu 1 square by 2. Okay. Then here we can calculate P1 because PT is 13.5. This is 10 into 1 plus mu 1 square, a single unknown value. From this equation we can calculate mu, and mu 1 is equal to 0.83 actually. Okay. Now mu 2 is given as 0.6, 60% of modulation. Mu 1 is given, mu 2 is given, then mu equivalent we can calculate by just integrating 0.83 square plus 0.6 square. Then PT will be what? PT is equal to PC into 1 plus mu equivalent square divided by 2. PT mu equivalent we can calculate by this expression, and then putting the value here we can calculate PC is already we know, then we can calculate the PT. That will be approximate 15.8 kilowatt. I hope there is no doubt in this problem. Everything is clear. Okay. We are going to next topic. We have already talked about the mu under critical situation. Under critical, we are just repeating to understand. Under modulation, critical modulation, and over modulation. These three terms we have already seen. When there is a under modulation, when mu is 0 to in between 0 to 1, and when critical modulation happens when mu equal to 1, and for over modulation the condition is mu is greater than 1. Okay. First we will see under modulation. Under modulation, that means mu is equal to what? M by NC, that is less than 1. It means AM is always less than AC. Okay, AM is less than AC. We are not increasing the message signal amplitude from what maximum amplitude of carrier signal. Okay, at that time, what will be this our graph will be like that. This is the envelope and this is the our A modulated signal, so on. I hope it is clear na, and it will give us A min and this is our A max. We have already calculated the value of A max and A min. And what will be the A min? We have what we have calculated, AC into 1 minus mu, and A max is what? We have already calculated AC into 1 plus mu. Okay. For critical modulation, second we are talking about critical modulation. Critical modulation. In critical modulation, mu is equal to 1. It means AC by AM is equal to 1. It means AC is equal to AM. Both are same. Amplitude of carrier and maximum amplitude of carrier and maximum amplitude of message signal is same. It means what will happen? We will get like that one. We are touching the x axis here, and what will be the our modulated signal? I am not drawing so clear. Okay, I hope you will understand what I want to explain. That this will be the our AM signal. Okay, and what will be the A min in this case? A min will be AC into 1 minus mu. Mu is 1 here, so then it is 0. Okay. Next, for over modulation, we are talking about over modulation. What will be happen over modulation? Over modulation system. In over modulation system, we are just mu is greater than 1. It means AC by AM greater than 1. It means AC, sorry, AM by AC. Here I am writing wrong. AM by AC. AM is less than, sorry, AM is greater than AC. Okay. It means message signal, maximum amplitude of message signal is greater than maximum amplitude of carrier signal. Then what will happen? We are crossing the x axis. Then what will we get? So this is, and this one. So it means what uh, uh, what will be the signal? Signal will be like that. What we don't know. And here what it is not the same signal. What we want to basically we have crossed x axis, then phase will be changed, and it is not the same signal what we are transmitting. If you talk about the envelope, what we got after demodulation, it is not same. It means at the time of demodulation we will not get that same signal. It means at the time of overmodulation we cannot demodulate the signal. I hope it is clear. Now we are talking about generation of AM. how we generate the AM signal, generation of AM. Okay, for generation of AM we have basically two methods. First one is square law modulator, and what will be the second? Second is our switching modulator. Switching modulator. First, a square law modulator. Square law modulator. What is the circuit of a square law modulator? Basically, what and we will try to understand how it works. Okay, the in square law modulator we have just empty. This is empty basically, and this is our summation sign, not multiplication. And what we are doing, we're just giving carrier here. This is the carrier, our carrier. Okay, AC cos 2 pi f ct. Okay, ct we can write AC cos 2, and then a square law device. A square law device. We will discuss in brief what is the square law device. And then a band pass filter. Then we will get a modulated signal. Okay. Here empty is the summation block is clear, BPF is clear, that is band pass filter. But what is square law device? Square law device works on square law device is just a diode or another thing, which what is the transfer function of our square law device? Input in, suppose input in this x axis, then what is the output? Output is like that, like this one. This is the characteristic of our output. Suppose this is V naught and this is V in, then V out is equal to A1 V in or V1 V in plus A2 into V in square plus A3 into V in cube, so on. This is the expression for our V naught. Okay, it means it will gives our us not only the first power of output, but second power, third power, and so on. This is given by our diode. Basically, this is the circuit. What this is the output. What will we achieve by using diode? Okay. In diode, what we see, there is basically two parts. The diode characteristic we can derive in two parts. One is this, and another one this. This is the linear characteristic. Linear characteristic, and this is the our square law characteristic. For I'm our interested our interest in this portion. This is the square law characteristic of a diode. Our interest in this portion. Okay, it means when we are giving input, what we want to do, we want to try to keep in this portion, so we can get the square law characteristic. Whatever we have written here, square law equation, it is only achieved at this position. If we are using diode, then if you are using diode, then this is the linear characteristic. We are not interested in linear characteristic, we are interested in square law characteristic. I hope it is clear, na? Then what will be the output? For output will be diode circuit. For this one, I am talking about only this one. This one, it will be, this is MT plus CT. This is the input here this is what we are getting here. This is MT plus CT. Then MT plus CT. Then our output will be V out is equal to V1 A1 V1 plus A2 V is here V n V in square plus A3 V in cube, so on. It means first here we can write A1 into MT plus CT. Second, A2 something constant into MT plus CT whole square plus A3 MT plus CT whole cube, so on. We are just putting the value of MT, just suppose CT value uh, value of CT and MT. What we will get? We will get the expression of AM. What we will get not only second frequency, the second multiplication, but also third and fourth and so on. But using band pass filter, we will filter out all the high frequencies. Okay, then we will get the AM output. Okay, just I am explaining that one. That first we are putting suppose SCT value we what we are doing, just putting value of CT, that is AC cos 2 pi FCT. Then putting here AC into cos 2 pi FCT, what will we get? A1 into MT plus AC 2 cos 2 pi FCT. Okay, and plus A2 into M square T plus C square T, and it means AC square cos 2 pi FCT plus 2 MT into here we are writing 2 AC MT into cos 2 pi FCT plus A3 into so on. What we are here, we will try to find out the interesting, the whatever we have interested. Then our interest in this signal, also this signal, and we have to remove all other another signals. Then we will get the AM output by using band pass filter as well as basically band pass filter. Then we will get what? In the band pass filter, we will what we are doing, just we are using band pass filter. The center frequency will be FC, then it will be the cancelled out, it will also cancelled out, and it will be also cancelled out because it is the 2 FC, basically 1 plus 2 cos 2 pi 4 pi FCT. It will remain this one and this one. I hope it is clear. If you have any doubt, then please ask me on chat box. I will try to give the answer. For today, I am stopping here. Thank you for watching. Thanks a lot.